Right, welcome to today's stream. We're going to be looking at differentiation and gradient. And our first question we've got on the board today is this one. It's a 10 marker, but this is previously an AS question, so it should be quite straightforward for year 2 mathematicians. So I'm going to give you 5 minutes to have a go at this one. One minute to go. Right, so let's go through this question now. And I've just noticed my pen is not ready and able to work, so just give me a second to get that online. I apologise for that. Do many stream texts before I start, and unfortunately today I forgot to do that one. Now all it just means is allocating the right work area to my pen, and we are ready to go. So here we go. We want to differentiate this. So we want divided by dx. We're going to differentiate this. So times by the power, and we take one off the power. If we times by this power, we are going to get 12 divided by 4 is 3 times 5 is 15, x to the quarter. And then we're going to times by this power, so we get minus 5 ninths of x. Take one off the power, and this just goes to 0. So that's that one differentiated. Hence, find the coordinates of the stationary point on C. So if we do that, we're going to solve 15x to the quarter minus 5 ninths x equals 0. And if we rearrange this, so take this to the other side, we get 5 ninths x equals 15x to the quarter. And what we can then realize, if we divide by x to the quarter, that will give us x to the 3 quarters. And then we can divide by the 5 ninths, and that will give us 27 here. Divide by 5 gives you 3, times by 9 gives you 27. And then undoing this, we cube root first, we get 27 cube root is 3, and then do the power of 4, that gives me x equals 81. And then we can put that number back into the y value, and we can get y out as 93.5. Now, let's just have a quick look at what happens when some things on our calculator, to make sure you are fully aware of all the things you can do on this. First of all, I need to go back and change the type of calculator. I'm just going to delete this one actually first. Okay, so we're going to type in the original equation, so 12, what we got, x to the power, and we want a fraction, we got 5 over 4, and then we're going to go minus fraction 5 over 18. Unfortunately, that's gone the wrong place. Let's just sort that out. Press that arrow. Minus fraction 5 over 18 times x squared minus 1000. Press execute and get it to draw, and it doesn't appear on our graph. Now we know that my value gives me 81 when y is 93 is a turning point, so I definitely need to change my view window. So let's change that from naught and go all the way up to 100 and do something similar. Just draw that view window. We've got the line going through. Let's just go down to the y values. Let's go from naught and then make that one 102. I probably should have changed the scale from 1. Notice we've got all these dots for all the scale, and we can see our graph. Now, quite a useful thing is to use the graph solve, and we can look for the max value that it's going to give us, and it tells us x is 81, y is 93. So you can do all your working and then check it on your calculator to make sure you've not made any mistakes, and we've got a maximum. So that helps us for the next bit to check we get the next part right. So part C, we want to find the second derivative. Okay, so we differentiate again, we times by a quarter, and we get 15 over 4 x. Now we're going to get to minus 3 quarters, and then we're going to just get minus 5 ninths. And then we put x is when x equals 81, we can see that when we get this, we're going to get quite a small number here, and then we're going to get minus this, and that's going to give me a negative answer. So therefore, d2y by dx squared is less than 0, therefore a max. And if you're running short of time, you've done this on the calculator, you can save yourself a bit of time just writing that out, and just that's enough working to show that you know what you're doing on this question. All right, so you can save yourself a bit of time. You don't have to find the value of d2y by dx squared. You just need to know the nature of it to make sure you get this question right. So one interesting fact I want to just do on this revision series is talk about increasing and decreasing. So the function is increasing all the way up until this point. So when x is less than 81, your function is increasing. And when it's greater than 81, the function is decreasing. Okay, it's worth pointing that out because that will come up quite often. Anyway, page down, list question. I haven't got a timer for this because I don't think we're going to use the full 5 minutes on this one. So I'm going to give you 3 minutes. My stream says 0:13:20, so I'll go through this at 17 minutes on my stream counter. Right, so you can see I've already typed in the function here. Might be useful to type it in before we even start the question. So let's do that for this one. Press draw. And we've got our graph here. We can see that we've got a minimum point going on back here. Now, that might not be all the turning points. Let's just change my view window. Let's just initialize that and see. Let's go standard, actually. See what happens and draw that. And we can see we've got 2 turning points going on in this question here. So let's look at them. We can just quickly use the graph solve to find where the maximum one is, and that's when x equals 1. And we can use the graph solve again to find where the minimum one is, and that's when x equals 3. I just want to check I've typed that in correctly. Okay, there we go. So let's get on with doing the proper maths. So we've got to find dy by dx. It asks us to find that. So dy by dx will equal times by 3, x squared, minus times by 2, 4x, plus 3. And now we know that we've got part A, so part B. So we want to find the set of values when dy by dx is greater than naught. Okay, where the derivative is greater than naught. And again, if we go back to this, it's going to be greater than naught up until that point, and then again after this point. So what we're looking at, the boundary values are when this is equal to naught. Okay, because obviously you're going to have greater than naught either at points where this is either side of the boundary points and this, because that will give you when it's equal to naught. So therefore we can find out where it's greater than naught. So we get x minus 3, x minus 1 as our factors. So that gives me x is equal to 1 or 3. Now, if you're cheating, you could just use your graphical calculator to help you here. And actually, as you've always got an exam, I would use it to help you in here. And we can see that x must be less than 1, and x must be, so we press union, x must be greater than 3. And if we want to put that into set notation, we probably should say x such that x is less than 1, union with, oops, let me just give myself some more space to write x such that x is greater than 3. And that gives you the set notation, which some exam boards ask for when showing the values. So that's where it's, both these areas are where the graph is increasing. In between it, you can see the graph is decreasing. And we use the strictly, when it's saying increasing, we use the strict values to say that it's increasing. Okay, so next one. We're going to have a look at this one. And it's a 6 marker. Again, I'm going to give you, it's only a straightforward differentiation. I'm going to give you 2 minutes to do this. If you're in the upper 6 now, you should be able to do this in 2 minutes. Right, okay, that should have been enough time to do that question. This is again set as an AS question originally, so therefore it shouldn't take too long for somebody in the second year of the course to do. So we're going to differentiate this. So we get dy by dx. Now, first of all, actually, what I'm going to do, I'm just going to write this down in terms of powers of x. Now, a common mistake here is to write this as 2x to the minus 1 and not have the half here. Then we've got x to the 4 divided by root x and 2 divided by 5. So you get 2/5 for the 2 divided by 5. X to the 4 divided by x to the half will give you x to the 7 over 2, because 4 is 8 over 2. Take away a half gives you 7 over 2. Minus 8/5, and we've got x and minus a half. And now it's ready for us to differentiate. Some of you may be able to differentiate it straight off in your head, but I would suggest you simplify this to make sure you don't make any mistakes. So we get 2 times 5 is 10x, times by minus 1 gives minus a half x and minus 2, plus times this by 7 over 2, so that's going to give me 7/5 x to 5 over 2, and then I'm going to times this by minus a half, so I'm going to get plus 4/5 x to the minus 3 over 2. And when I did this previously, I did have another go at trying to simplify this further and make it look as neat as the original question. And this could be an exercise for you to have a go at. I don't think actually adds anything. I think this is a perfectly good answer to the question. And this is what I mean by simplify. They get the fractions down in the simplest terms, really, on this question. Because if you get it into this form, so you can get it into this form. So this becomes 1 over 2x squared. And then if you, a little algebraic exercise could be for you to have a go at getting 7x squared plus 4 over 5x root x. Now, I don't think this actually adds anything to this question, but you might want to try it as a little algebraic exercise. Anyway, next question. Here we go. Let's just scroll that down so you can see all of it. I'm going to give you, it actually is a really quick question once you've got through the differentiation. So I'm only again going to give you 3 minutes to have a go at this, even though it's a 8-mark question. Again, it's another AS question. You should be able to do this quite quickly. Right. So let's have a little look at this question. So we're going to use calculus to find the coordinates of point A. So let's just do that. Let's put part A up here because I've got some space up here to work with. So we've got f of x. I'm just going to rewrite this as 8x the minus 1 plus a half x minus 5. And therefore f dashed of x will equal minus 8x to minus 2 times by the power, take 1 off the power, plus a half. Oops, started writing an x there, didn't need any of that. Now, I want to find the turning point, so therefore that's going to be equal to that, naught. Take the half the other side and change the sign of everything, so we get a half equals 8x to minus 2, so that's 8 over x squared. Now, if I times by x squared and times by 2, I'll get x squared equals 16. So x equals plus or minus 4. In this case, x will equal 4 because it's quite clearly this is a positive value. So therefore, if we put that into here, we can find out that y is equal to minus 1. When we do 8 divided by 4, half of 4 minus 5, we get the coordinates of the point 4 minus 1. Now, state the roots of the equation 2f of x equals 0. Now, obviously, with today's graphical calculators, you are probably unlikely to get a question like this where you're given the function and then they're given the transformation. They'll probably not give you the equation of the function because you could always just times this all by 2 and put it into the graphical calculator. But we can find the roots of the equation. Now, 2f of x means we just stretch this way, parallel to the y-axis, scale factor 2. So that won't change the roots of x. So therefore, the roots of x are still going to be 2 and 8. Okay. Part 2, the coordinates of the turning point on the curve of y equals f of x plus 2. Now, this plus 2 just translates our graph up by 2 units. So therefore, that's what's going to happen to our turning point. So our turning point at 4 minus 1 will go up to the point 4, 1. Part 3, and because it just says state, we don't have to say the reasons, which I'm giving you, but I'm giving you the reasons to help you with this question. The roots of the equation f of 4x equals 0. So we're going to take if the 4 goes inside the function, then the movement's going to be parallel to the x-axis and the opposite of what you expect. Now you expect this to stretch out, and it's not. It's going to squash it all up. So therefore, it's going to stretch scale factor a quarter. So therefore, this is going to be a quarter of 2, which is going to be a half, and this one's going to be a quarter. This one here is going to be a quarter of 8, which is 2. So those will be our roots for that one. Right. Okay. How long have we been going for? Half an hour. I'm just going to finish off, I think, with one more quick question, just to check you know how to find the range of x values for which f of x is an increasing function. Do this by differentiation, not by cheating with your calculator, but you can use your calculator to check your answer. I'll give you 2 minutes to do this because it's an easy derivative to work out. Let's have a go at putting your answers into set notation. Right. So as you know, to find where it's an increasing function, we need to find the gradient. So therefore, we need to differentiate. So we get f dashed of x is equal to just x 3x squared minus 12x. And then we can put that equal to 0 to find our limits of our inequality, where the derivative is equal to 0, and therefore we can find out where it's positive and where it's negative. So we've got 3x squared minus 12x equals 0. So factorize this out, we get 3x x minus 4. So x will equal 0 or x will equal 4. Now, if we draw a little sketch of this, there's 4, there's 0. Now we can see that our gradient, this is our gradient. So the value of this is going to be positive when we're less than 0 and bigger than 4. So we're going to have x is less than 0, union with x is greater than 4. And if we're using set notation for that, we should use x is curly brackets, x is such that x is less than 0, union x is such that x is greater than 4. And if you just check with our graphical calculator, so we're going to press that, draw it, we can see our graphical calculator. We're looking for increasing function, so it's increasing, the gradient is positive here, and the gradient is positive after here. We might want to just see if we can move down a bit. We could use our graph solve to find where that minimum point is, just to check. And you can see it's at x equals 4. And we know after that point we've got an increasing function. Go back to graph solve, we can find where the maximum is just to check. So it was 0 and 4, the two values given to us. So there we have it. That's all for today, doing differentiation. We're going to jump back into mechanics for our next session, which will probably be Monday at the same time. Keep a lookout on the channel and you'll see that will be updated in due course. Thank you.